Welcome to a rare early morning video. I'm not going to have too much time for this video, but I think a good half an hour is all I'm going to need. So last video we finished up the exercise for how to remove community tag attributes, the community path attribute from a route. So now we're going to do an exercise where instead of removing one, we're going to be taking an action based on that BGP community. So this is kind of the meat and bones of what that community was for before we learned how to add and remove those communities. Now we're going to learn how to take actions based on the path attribute that is assigned, the community path attribute. All right, so overview. This example shows two routing devices with an external BGP, eBGP connection between them. Device R2 uses the BGP session to send two static routes to device R1. On device R1, an import policy specifies that the BGP received routes can receive up to 5 communities to be considered a match. For example, if a route contains 3 communities, it is considered a match and is accepted. If a route contains 6 or more communities, it is considered a non-match and is rejected. So communities are optional transitive. So that means they're going to be passed on, of course, unless there's a policy that removes them. So as it goes through a router that adds a new community, it's just going to be building up communities. So this is a way you can check if where your routes came from, aside from just the AS. You can tell within an AS the journey your routes have taken, and if it's gone through too many from the other AS or from your own AS, you can reject that route. It is important to remember that the default policy for eBGP is to accept all routes. To ensure that the non-matching routes are rejected, you must include a then reject action at the end of the policy definition. So yeah, this is really important. And the other thing about it is it's different from ACL. So standard ACL, the default is to deny any at the end. So here, the default is to accept all routes. All right, so let's get to the configuration. Looks like it's going to be very similar to what it was above, but I would like the further practice just on the command line. Oops. And remember that an import is going to apply to a routing protocol, and it's going to determine how routes are moved from that routing table to the routing protocol to the routing table. An export determines how they're moved from the routing table to the routing protocol. So the other thing we learned in the next video, you're not going to be able to do a Wireshark sniff on imports because it makes that decision after the traffic has already arrived, whereas for exports, it's going to make decision and then it's going to send it out. So you can see the results of your configuration in an export statement by sniffing the link because it's sent over with those results. but for an import, it's sent over as it's sent over. And then after you receive it, you do the things in the import statement. So you will not be able to see it in a Wireshark capture. All right, and let's take a look at, in closer detail, some of the other options we've got for the from here. So we've got community, community count, condition, color, or color to. Let's take a look at each one. So preference. Yeah, so we've got more options there. We're going to go with community count. So number of communities, and let's do 5, and then match equal values, match higher or equal values, match lower or equal values. We're going to have or lower, so that's going to include the 5. And now here's where we're going to need that then reject, because unlike an ACL, if you didn't include that statement, it wouldn't be there implicitly and do that by default. It would have an accept statement implicitly and do that by default. So we don't want that to happen. I'm kind of confused why this is necessary if that is the, oh, okay, yeah, I see, yeah, because you want from BGP, from community count, those accepted, then you have reject. So you do really need this statement, because these don't mean that you're going to accept them. They don't have any meaning as to whether they're accepted or rejected. It just means you're going to look at those, and then the decision you make on them is based on this command here. You're going to accept them. And this is all happening in term 1. The next term, you're going to reject anything else that doesn't match these. So it's going to evaluate it based on the order of the terms. First term looks at BGP traffic, looks at community count, and if there's 5 or fewer communities, then it accepts the route. Second term rejects everything else. Okay, and I'm going to take the liberty here and add the word passive to make those Wireshark captures a lot cleaner. Otherwise, we would have that race condition where the neighbor that initiates the BGP connection is dependent on the IP, source IP of those initiations. And I believe the higher one is the one that wins. I actually don't remember. I don't think it's going to be all that important to remember. The main thing is just that you can prevent that by using the passive keyword. And that's nice because you can get rid of unnecessary control traffic, and you can make your Wireshark captures a lot prettier by doing that. So your network runs smoother, your Wireshark captures are prettier. It just makes sense to use that passive command. I mean, there could be an issue where one side is not as good at initiating it as the other, and then you get the advantage of, if you don't know which side has the problems. But even then, it's based on so even if one is somehow disadvantaged in sending the initial sync or SYN message, TCP SYN, to try to initiate the handshake, even if one is disadvantaged in doing that, it won't pick the one that has the advantage. It'll pick based on the IP addresses. So there's just a time window when it tries to send that. So there's really no advantage at all in configuring a BGP neighborship without using the passive keyword on the side that you want to respond to the three-way handshake, to send out the SYN ACK. So if we remember from here, this right here is our community. This is just the ASN, and that's something that has to be specified. So ASN community ID. So our community ID here is 1. And our ASN is 2. And we're sending these over to ASN 1, I believe. Yeah, pure AS1. So we're sending these over to AS1. So we can see that this is going to be rejected because there's going to be more than 5. It's going to be 6 or more communities appended to these routes. So this route will not be accepted as per that import policy on router 1. Oh, it's not policy options, it's routing options. All right, everything looks good to go. Hopefully that will commit. Oops, and I did want to do a Wireshark capture on that just to see this coming up. So I think I'm going to roll this back. And now, before I issue this next commit, I'll start the Wireshark capture so we can see that neighborship is going to be nice and clean. It's going to be initiated from router 1. And we'll see BGP update message that will have all those communities in there. But when we go to router 1 and look at the routing table, we will see that it actually does not have those communities because of that import policy. So let's find our TCP SYN. So here it is. For some reason, looks like there was an issue, or maybe it just takes some time to come up. Let's take a look at Bgp Summary. So yeah, it looks like it's still working on coming up. Aha, here we go. So it takes a while for the BGP session to open up. Kind of curious why it takes so long, but let's review our neighbor states. So it's going to be active, connect, open sent, open confirm, established. So let's see if we've got all those. We've got active. We've got, oh, it went right to established. Sometimes it goes really fast and doesn't show all of the states. But if you look at the previous state, you can see it's always going to be open confirm if it were in open established, or if it is currently established. So let's see. Yeah, so everything looks good. Let's look at the Wireshark capture. You can see we've got our gratuitous ARP because the interface now has an IP. We actually took the interface out. Looks like it's actually not a gratuitous ARP, it's just a regular ARP. It'll say gratuitous ARP if it's gratuitous. And gratuitous means it's just sent out just for the sake of making sure that those tables are up to date, not as part of any regular process. There are some vendors that don't have gratuitous ARPs, so then you'll end up in situations where, oh no, it's not mapping the IP address to the MAC address. You will either have to manually ARP it by pinging, or you're just kind of out of luck, like it's not going to do that unless you trigger an ARP message being sent through some process. But you can see the first SYN was actually missed, or actually it was responded to. The first SYN did receive a response. Let's look at this some more. So what's this RST flag? So reset. Okay, so it basically said it's not ready. Let's read the TCP flags just to get more familiar with them. So there's reserved, nonce, congestion window reduced, CWR, ECN echo, urgent, acknowledgement, push, reset, SYN, and FIN. Those are the TCP flags that you can have. In this case, we're going to have the acknowledgement. So it did a SYN-SYNAC, but it wasn't ready yet. It was still loading in that configuration. So reset, send it to me again, I'm not ready. So yeah. So it was happy to oblige. It just sent it again, and now it's ready to go. The BGP process, port 179. And the other thing that's interesting is this was replied back to by port 179. So this was definitely the BGP protocol not yet being ready to respond to that SYN. It was just sent out too early, and all the configuration hadn't been ready to go yet. So the BGP protocol, port 179 that will then port, says, I'm not ready yet, reset, send it to me again, and I'll respond once I'm ready. So that happened here, SYN, SYN-ACK, three-way handshake. Starting from .1, we don't see an extra message. We don't see any extra fin messages too for that race condition because we've got the passive keyword on there. Then we've got our good old-fashioned open messages that you've got to establish the three-way handshake before you can open a actual BGP communication neighborship. So that takes its own message. So let's take a look at that. So here's an open message. We're exchanging our ASs, exchanging BGP identifiers. There's a bunch of optional parameters. Oh, it's MP BGP. I'm pretty sure that's like just the default. Like it's not like you just enable MP BGP. It's like I would like to know more about that because there's always a distinction between BGP and MBGP, but I haven't really seen where you would make that distinction in the actual configuration. I mean, I guess it's dependent on the families that you're advertising, the address families. If you're advertising things that aren't just IP protocol, then you're very likely using multi-protocol BGP, so like MPLS and stuff. Okay, so this one was from .1. So now we got another from .2. We also got a retransmission. So .2, same old stuff. But now here's our key messages, our updates. So here's the update from .1. Saying just a regular old update message, no withdrawn routes, empty blank message. But here's the main one with the patch attribution, all of our communities that we added, and the 2 routes that we added as well. So that's all there is to that. Step-by-step procedure. Let's see if there's any extra information. Nope, looks pretty sparse. So you can configure multiple communities or configure a single community with multiple members. So what we could have is, instead of community 1 with all of these members in it, we could have a community for each member. It looks like there's no recommendation or advice about which one's better. It just depends on what you're trying to do, the one that you would use. This I wish they would have more information about. I kind of am curious why you need a reject and an install keyword. That is not clear to me. So let's go routing options static set route 10.2.0.0/16, and now let's see what this means. So I'll just filter it. So reject, drop packets to destination, send ICMP reachables. Okay, what does install mean? Install route into forwarding table. Yeah, so I would like more information about that. Let's go to Google quick. I've only got about 10 minutes, but that is leaving a lot to be desired for me. So let's see if we can get some more information. Here we go. So here's for install. What about reject? So let's read about this. Description: configure whether OS installs all static routes into the forwarding table. Even if you configure a route so it is not installed in the forwarding table, the route is still eligible to be exported from the routing table to other protocols. Install. Explicitly install all static routes into the forwarding table. Include this statement when configuring an individual route in the route portion of the static statement to override a no install option specified in the default portion of the statement. And then no install, do not install the route into the forwarding table, even if it is the route with the lowest preference. Okay, so I think I understand what's going on here. If you were to just straight up create a static route, yeah, it would have pretty low administrative distance, but it wouldn't have an eligible next hop. It would be leaving much to be desired. And through the natural process of what it takes to add something to the routing table, it wouldn't make it through. It would be rejected through the natural decision-making process for whether or not a route in the routing table then gets used in the forwarding table to actually make forwarding decisions. So if I do a run show route, we can see that these are static routes. Yes, they're set up with reject. Let's take a closer look. So maybe even detail on them. But kind of long story short, we need that install keyword. Let's show forwarding table, or run show forwarding, or show route forwarding table. Let's see how that's different. And hopefully we can get an address or further filter that down. Destination prefix. Oops, that's detail, not destination. So here's the forwarding table. So we've got no next hop. I think all this means is it's just what happens when you try to use that route. You'll get an ICMP unreachable message. So you can see the route is in the route. Well, it's actually not in the routing table. Oh, and right, it's because it was rejected. But if we actually try to ping anything in this route, we're going to get an ICMP unreachable message. Oh, right, because it's a hidden route now. God damn it. But that's something I can look at closer in the next video. But I think I understand now what it means to have that no install. Let's look up the reject. Do not forward packets addressed to this destination. Instead, drops the packets, send ICMP unreachable messages to the packet's originators, and install a reject route for this destination into the routing table. So let's hopefully quick in the 4 minutes I've got, go ahead and get rid of this import statement. So we're going to do delete import, show pipe display set, commit. So now those are not going to be hidden routes anymore because we're no longer checking their community attributes and denying them if they have 5 or more. So now if I ping something here, I am going to have a route to the host. But aha, so here you can see destination net unreachable. This is an ICMP message. If I pull up Wireshark, run that again, we're going to see some ICMP traffic And it's because we told router 2 to say, hey, if anything comes to this route, if any traffic comes here, well, we're just using it for learning purposes, or you know, whatever purposes you would want to have that reject knob toggled on your route. So if anyone actually tries to use it, you know, just tell them it's unreachable. So, aha, so yep, we can see ICMP, and we can see that it's gonna say unreachable. I mean, we saw that it said that already, but it looks like it doesn't say it in here. But it's evident from the command line. So if I were to, I'm gonna check that it's running again. So yep, that's still running. But if I were to go to router 2 and remove those reject statements, so show type display set, so remove these rejects, I only needed to do it for the one that I'm pinging, but I don't remember which one that is. So now we're no longer going to get those ICMP responses. Oh, it looks like we still got those ICMP responses. Oh, okay, because it did not. Aha. But you can see we can't even install it in our routing table now because we don't have that next hop. This is how you can say, this is a dummy route. If anyone tries to respond, tries to ping this, if anyone tries to use it, just send ICMP traffic saying that it's unreachable because it's just a dummy route I'm using for whatever the heck I want to use it for. But please do on me, you know, this is for you. If you want to use this route, I'm going to tell you destination host unreachable, and I'm going to send you a reject message. But when I use this route, this knob says, use it for forwarding decisions. Please do put it in the forwarding table and actually send it to people. But if they actually try to use it, let them know that, you know, this is just for educational purposes or whatever purposes. It's not for actual traffic. So tell them destination net unreachable. So I actually can't remove that statement, because if I did that, it would be treating it as though it were a valid route, but it would not be including all the information it needed to be valid, such as the next hop. Okay, so now that everything is set back to normal, I'm going to stop the capture. I'm going to take a look at the documentation. And I'm going to leave it here and come back later and look at the verification steps for this. So thanks for watching. We learned, we reinforced what we already knew about race conditions, used that passive keyword to make the Wireshark look better. We configured a routing policy that instead of removing communities, it filters routes based on the communities. So I'm going to change that. That filters routes based on the community. And then finally, the last thing we did is learned more about what it means to include the knobs reject and install in a static route. So thanks for watching. Stay tuned for the next video where we verify the exercise.